Hello everyone. On this video we will be going over the different properties of logarithms. Okay, so starting off we will go over the multiplication property, or sometimes it's called the product property of logarithms. Okay, so for this one we're going to use an uppercase M and N. So for all positive real numbers, M and N, and if we have a base that does not, a positive base that does not equal 1, log base B of M times N, you can separate that into log base B of M plus log base B of N. Alright, so starting off, we'll do a couple of examples using the multiplication property. Okay, so for example, we want to write each as the sum of logarithms and simplify. Okay, so for problem A, it's log base 2 of 2 times 7. Okay, for problem B, so if you have log of 100 times x. And for problem C, let's say if you have log base 5 of 125 times y times z. Okay, so starting off with problem A, again you have log base B of M times N equals log base B of M plus log base B of N. Alright, so using that formula, we know that log base 2 of 2 times 7 is equal to log base 2 of 2 plus log base 2 of 7. Okay, now even though we've separated it, it doesn't mean we're done, because this can actually be simplified. Okay, so if we simplify this, we can rewrite it as log base 2 of 2 equals y. Okay, so from logarithmic form, we can convert that to exponential form. 2 to the power of y equals 2. So 2 to the power of y equals 2. Remember, 2 is the same as 2 to the first power. So our bases are the same, which means those exponents have to be the same. So that means that y is equal to 1. So this entire term here is just equal to 1. So that gives us a final answer of 1 plus log base 2 of 7. You can't really simplify that. So that just stays log base 2 of 7. Okay, so that's your final simplified answer for that one. Okay? Let's go to problem B, where we have log of 100x. Okay, now remember, when there's no base, it's a common logarithm, so when there's no base, our base is automatically assumed to be 10. So this becomes log base 10. of 100 times x. Okay. Now, since we have a product inside of here, we can separate those using the very same formula. So that's log base 10 of 100 plus log base 10 of x. Okay, so you see here, this can actually be simplified. All we have to do is rewrite it. We have log base 10 of 100 equals y. If we convert that to exponential form, 10 to the power of y equals 100. So 10 to the power of y equals 100. We know that 100 equals 10 squared. So it makes that 10 to the power of y, 10 to the power of y equals 10 squared. So if your bases are the same, your exponents have to match. So we know that, put that underneath it, y equals 2. Okay, so this entire term is equal to 2. So that gives us 2 plus log base 10 of x, because log base 10 of x can't really be simplified any more than that. Alright, so we're going to go ahead and solve C using the very same method. Okay, so for problem C, we have log base 5 of 125 times y times z. Okay. Now the thing is, it doesn't matter if you have 2 factors or 3 factors, you can separate them all the same way. Okay, so this one, you can just rewrite it as log base 5 of 125 plus log base 5 of y plus log base 5 of z. Okay, so if you had 125 xyz, you would just have 4 terms here. You have the 125, the x, the y, and the z. Okay? Now these two, you know when you have a log of an actual numerical value as your base, and that's of a variable, it can't really be simplified. At least those two can't be simplified. But this one can be simplified. Okay, so just like before, we're just going to make this equal y. So log base 5 of 125, make that equal to y. Okay, so if we go ahead and convert that to exponential form, 5 to the power of y equals 125. Make sure that looks more like a y there. There we go. Okay, so we know that 125 is just equal to 5 to the 3rd power. 5 times 5 times 5 is 125. So we have 5 to the power of y equals 5 to the 3rd power. Okay, so our bases are the same. That means for this to be true, our exponents would have to be equal. So we know that y is equal to 3. So this entire term right here is equal to 3. So that gives us 3 plus log base 5 of y plus log base 5 of z. All right. Okay, so if you're still writing, please feel free to press pause, but we're going to go ahead and move on to our next property. Okay, so that's the quotient property of logarithms. Okay, and that one's just a little bit of a tweak on or from the multiplication property. Okay, so for all positive real numbers, m, n, and if we have b being a positive number that doesn't equal 1, if we have log base b of a quotient of m divided by n, that's going to equal log base b of m minus log base b of n. Okay, so you see with the multiplication property, it was plus. With the quotient property, it's minus. Okay, so that's just a little difference between the two. All right, so let's do our first example with our quotient property. Okay, so let's say, for example, if we wanted to simplify log base 4 of x over 64. Okay, so solving that one, we're going to use our quotient property because we have a quotient. So log base 4 of x over 64, that's going to equal log base 4 of our numerator, which is x, minus log base 4 of our denominator, which is 64. Okay, now just like before, if you have a log of a base of a numerical value and just a variable, that pretty much won't be able to be simplified. But this can be simplified. Okay, now first thing we do is just make that equal to y. So log base 4 of 64 is equal to y. Okay, so then we get that and we convert it to exponential form. So 4 to the power of y equals 64. Okay, so one thing you want to notice is that 64 is 4 to the third power. So we rewrite this as 4 to the power of y equals 4 to the third power. Okay, so our bases are the same. So that means our exponents would have to be equal for this to be true. So y equals 3. So this entire term is equal to 3. So that gives us a final answer of log base 4 of x minus 3. And that's your simplified answer. Okay, so if you're still writing, feel free to press pause, but we're going to move on to our next example. And this example will have a combination of both the quotient and multiplication property. Okay, so let's say, for example, if we wanted to simplify, say log of x times y over 10z. Okay, so it's a few things to remember here. Okay, first thing you want to remember is a common logarithm. So you have log of xy over 10z. That's the same as log base 10 of xy over 10z. Okay. So now, first thing we're going to do here is apply the quotient property. So that becomes log base 10 of your numerator, which is x times y, minus log base 10 of your denominator, which is 10z. Okay. Now, if you notice here, both of these have products inside of here. There's multiplications inside. So we're going to apply the product or multiplication property to both of them. Okay. So remember, and this is really, really important because it's a very easy mistake to make, that minus sign applies to this entire term here. Okay, so we have log base 10 of x times y. Let me give myself a little more room here. Okay, so that becomes log base 10 of x plus log base 10 of y. Okay, so this one term simplified to those two terms. Okay, so that's minus, and this is why I point this out. This becomes log base 10 of 10 plus log base 10 of z. Okay, the reason I point this out because the easy mistake to make is if you don't realize that this minus sign applies to this whole thing, it's easy to make the mistake of just saying log base 10 of x plus log base 10 of y minus, without the parentheses, log base 10 of 10 plus log base 10 of z. So if you don't have those brackets or parentheses there, you forget that now you have to distribute that minus. Because remember, this minus applies to this, and this is the same as both of those. Okay, so if we simplify this, it becomes log base 10 of x plus log base 10 of y minus log base 10 of 10 minus log base 10 of z. Okay, so you want to remember that whenever you have that minus, it applies to the whole term. Even after you separate it, it still applies to that whole term. Okay, so we know these three terms with the x, y, and z, can't really simplify those. But this, you can simplify. First thing we do is we make that equal to y. So log base 10 of 10 is equal to y. Then next we convert it to exponential form. So 10 to the power of y equals 10. Okay, so we know that 10 is the same as saying 10 to the first power. So as long as our bases match, this is equal only if the exponents are equal. So we know that y is equal to 1. So this entire term is equal to 1. Okay, so your final simplified answer is log base 10 of x plus log base 10 of y minus 1 minus log base 10 of z. Okay, so our final property is our power property. So if you're still writing, feel free to press pause, but we're going to go ahead and move on to our last property. Okay, so power property of logarithms. Excuse me. Okay, now for this one, we're having for all positive real numbers, and we'll just have m, and instead of n, we'll have a lowercase p, and we know that b, your base, does not equal 1. The log of base b of m to the power of p, we get that exponent and we just pull it down to the front, is equal to p times log base b of m. Okay, so that's the power property. Whenever you have an exponent, you just pull it right out to the front of your logarithm and multiply it. Okay, so let's say, for example, if you wanted to simplify log base 5 of 36. Okay, solution here. You want to note that 36 is equal to 6 squared. So log base 5 of 36, well, that will just become log base 5 of 6 squared. Where for here, we apply power property. So that exponent just goes out to the front. So that becomes 2 times log base 5 of 6, which is your simplified answer. Okay, can't really do anything else with log base 5 and 6. All right, so let's say for our next example, we want to simplify log of square root of 10. Okay, now to do that, you want to remember that square root of 10 is equal to 10 to the 1/2 power. Okay, kind of going back to our nth root properties. Okay, so that means, oh, another thing we have to note, and we know that log of square root of 10 is equal to log base 10 of square root of 10. Okay, so kind of two things you want to note here. So that means log of square root of 10, you can rewrite that as log base 10, and square root of 10, you can just rewrite that as 10 to the 1/2 power. Okay, and then we go ahead and apply the power rule, or power property. Okay, so that exponent just comes right out to the front. So they have 1/2 times log base 10 of 10. Okay, now this part, log base 10 of 10, that can be simplified. First, we make it equal to y. So log base 10 of 10 is equal to y. Then we convert it to exponential. 10 to the power of y equals 10. So 10 to the power of y equals 10. And remember, 10 is the same as 10 to the first power. So our bases are the same. That means this is only true if our exponents are equal. So you have y equals 1. Okay, so if we go back to this, just kind of giving you a trail of everything we did. We have 1/2 log base 10 of 10. Then this we realize equals 1, so that becomes 1/2 times 1, since that whole factor here is equal to 1. So our answer is just 1/2. That's our final answer. And make that 1 look a little more like a 1. There we go. Okay, so there are two key points I want you to remember, because these are probably the easiest mistakes to make when dealing with properties of logarithm. Okay, so the first thing you want to remember is that log base b of m divided by n does not equal log base b of m over log base b of n. The reason this is such an easy mistake to make is because it looks like it should be true. It's just not true. Okay, so that's a mistake. Okay, remember, log base b of m over n is equal to log base b of m minus log base b of n. Okay, this is true. And same thing here. If you happen to run across a log base b of m plus n, that does not equal log base b of m plus log base b of n. Okay, log base b of m plus log base b of n, log base b of m plus log base b of n is equal to log base b of m times n. Okay, so you don't want to confuse that. Like I said, these are really easy mistakes to make. Do not make these mistakes. Okay. All right. So hopefully this has helped, and I will see you on the next video.